All right, so remainder theorem. Now, if you have a polynomial, okay, so now if you're not quite sure what I mean when I say polynomial, polynomial is basically any expression. So an example is x squared plus 3x plus 5. Yes, it is a quadratic, but it's also a polynomial. Okay, or you could have x cubed plus 5x squared plus 3x plus 2. So these are basically polynomials. Okay, now if you have a polynomial and you divide it by a linear term, so x minus h, like that one, if you divide by that, then the remainder is p of h. What that means is, so whatever, was there a question? So whatever I substitute into the polynomial, the h into the polynomial, whatever I get is going to be the remainder. Okay, and if I divide by ax minus b, then I would have to substitute b over a. The reason I get that is this: ax minus b equals 0. Pretend, and then if I solve this, ax equals b, x equals b over a. Now, if I substitute this into my polynomial, whatever value I get is going to be my remainder. Okay, so this is basically the remainder theorem. So now let's use it. So you might get a question: find the remainder when this polynomial is divided by x plus 3. Okay, so we don't actually have to do long division for this. It's asking for a remainder, and it's a very common achieve level question, but no, we don't actually have to do long division. All we are going to do is you go x plus 3 is equal to 0. You don't even have to do this. You can do this in your head, but anyways, just demonstrating for people so you understand where I get the negative 3 from. So now I'm going to substitute negative 3 into my polynomial. So 4 negative 3 to the power of 3 minus 3 times negative 3 squared plus negative 3. Okay, now you can put that into your calculator, or perhaps you can just do it in your head. So 4 bracket negative 3 to the power of 3 minus 3 bracket negative 3 squared. Oops. Sorry, I'm going to have to start again. I accidentally cleared it all. Okay, so I get negative 138, and that is basically going to be the remainder. Now, if you wanted to check, you could. You can actually do the long division, and was it negative? Or just positive? It was negative. So it's negative 138. Okay, so that's basically what the remainder theorem says. So the next one, it says, example 2, find the remainder when 5x to the power of 4 minus 4x cubed, the whole polynomial written there, is divided by 2x plus 3. So now, as I talked about this before, what we are going to be substituting is not negative 3. So you're going to say 2x plus 3 is equal to 0. So 2x equals negative 3 and x equals negative 3 over 2. Now, what I want you to do is I want you to substitute that into the polynomial. I'm assuming you've got a calculator handy there. Okay, and then let's check that we both get the same answer. So go ahead, you do the substitution for me. And then when you've got an answer, just write it into the chat box. Okay, so hopefully you got 32.5625, which is what I got on the calculator here. So if you are okay with that, then we can move on to the next part. So the next part is, this is again, a common achieved type problems. So it says determine the value of P if 2x cubed plus 5x squared minus 5px plus 16 has a remainder of 10 when divided by x plus 2. So what they've done is they've given you what the remainder is and what they divided by, and they're asking you to work out the value of P. So we know that if I were to substitute -2 into that polynomial, I should get 10. Okay, so that's what we're going to do. So 2 times -2 to the power of 3 plus 5 -2 squared minus 5p -2 plus 16 should give me 10. So basically solving this equation gives us the answer to P. So I'll just do that for you. So that's -8 times 2, -16. And that's 4 times 5, which is 20. And that's positive 10p plus 16 equals 10. And just going forward, that's 4 plus 16, which is 20. So I've got 10p plus 20 equals to 10. 10p equals to -10, and p is equal to -1. So I've just worked out the value of P. All right. So these are the types of problems you are expected to do with the remainder theorem. Now, what happens if the remainder is 0? So when you're doing long division, if the remainder is 0, then it means it's a factor. Okay. Okay. So if the remainder is 0, it's a factor. And that's basically what factor theorem is. The factor theorem says that if you get a remainder 0, then what you're dividing by is your factor. Oh, there's another example here, which you could probably, as I said, I'm going to share this document with you and you can do this yourself. So here they've given 2 different conditions, like when x plus 1 is divided, the remainder is -10. And when you divide by x minus 2, the remainder is 26. And there's 2 different constants you have to work out, okay, A and B. You will get 2 separate equations and you work them out simultaneously to work out what A and B are. Okay, so it's the same understanding, except it's got 2 equations instead of just 1. Again, you can try that when you do this in your own time. Okay, so the factor theorem. So as I just said, okay, sorry, I'm trying to scroll up and it won't scroll up. Why is that? Oh, that's the highest it can go. Okay, now, so here we have, so we know that if you get, when you substitute A in, okay, because you're dividing by x minus A, and if you substitute A in and you get 0, then it means that x minus A is a factor. So first example here, determine whether x minus 1 is a factor. So all we're going to do is substitute 1 in. So let's see what we get. So that's 2 plus 3 minus 5 plus 7. No, it's not equal to 0. Therefore, x minus 1 is not a factor. Okay. Now, what we do is we use this theorem to factorize cubics. Okay, so if we know that if I substitute a number in, and that gives me an idea of what my factor is, I can then factorize a cubic. Okay, so of course there's a whole lot of possibilities. Am I just going to substitute a million numbers in and hope that I will find one that will work? No, we are actually going to do it with inspection and kind of thinking about it, thinking logically. So what you have to understand is this is a cubic, and if it's factorized properly, it's going to have 3 brackets. Okay, thinking about when you multiply it out, we know that these 3 last numbers multiply to 12, or negative 12. Okay, we know that. So we use that aspect to help us factorize. So I know that these are factors of 12. Okay, so I'm going to first list all the factors of negative 12. So you could have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Okay, so basically I have there 12 possibilities. Okay, because we're talking about positive and negative. I'm not going to try all of them. I'm really hoping just to find one, and then that will give me the chance to work out the others. So what we do is we substitute, let's start with negative 1. So P of negative 1. Now, if at any part you are not quite sure what I'm doing, please stop me, because I can't see what you're thinking. I can't see anything. It's like, I don't know if this is difficult for you unless you actually tell me. Okay, so there we go. So I've substituted negative 1 in. Let me see what it gives me. So that gives me negative 1 plus 3 plus 4 minus 12. Okay, no, that's not equal to 0, so that's not a factor. Okay, I'm now going to try positive 1. Okay, so that's 1 plus 3 minus 4 minus 12, and that's not equal to 0 either, so I have to keep moving. So I've tried those and they did not work, so I'm going to move on to positive 2 or negative 2. I'm just going to clear the bottom here to give me some room. Okay, so I'm now trying negative 2. Okay, so that gives me negative 8. That's 4 times 2, which is 12. And that's positive 8, and that's negative 12. Okay, that is 0. So when I substituted negative 2, I got 0. So this tells me x plus 2 is a factor. Okay, so watch that carefully. So I substituted negative 2, not positive 2, negative 2, and I got 0, which tells me it's x plus 2 that is a factor, not x minus 2, but x plus 2. Okay, because if x is equal to negative 2, then when I rearrange, x plus 2 is my factor. Okay, now that I know that x plus 2 is my factor, there are 2 ways I could go about this. I could still try and inspect further by going, okay, x plus 2 is one factor. What are the other ones? So I know that they have to multiply to 12. So the other ones must be multiplying to 6. So it's either 3 and 2 or 6 and 1. Okay, so that's, you can just try those and see. Another way to do it is just to do long division. Okay, so I'm going to do long division because I think it's a good way for you to see how to do long division, because we just learned it the other day and it's a good way to practice. So let's do long division. So x plus 2. Now, so the first thing is x times by what is going to give me x cubed. This x came from here, and the x cubed is from there. I know it's x squared, so I'm going to write the x squared there, and I'm multiplying this whole thing by x squared. So x cubed plus 2x squared. Now I'm going to subtract. Okay, 3x squared, take away 2x squared is x squared. And I've got x squared minus 4x. Now, x times what gives me x squared? And it's x. So I'm going to put x there. So x plus 2 times x will give me x squared plus 2x. Now subtract. It's gone. Minus 4x minus 2x is minus 6x. And bring down the 12. Now here I need a negative 6 because x times what gives me negative 6x, and it's negative 6. So when I multiply, I get negative 6x and negative 12. Okay, and that's eliminated and it's 0. So what I have here is this. I'll write up, actually, I'll clean this bit here. Okay, so what I have here is this. X cubed plus 3x squared minus 4x minus 12 is basically x plus 2 multiplied by x squared plus x minus 6. Okay, at this stage, I can factor out the quadratic. I can see that that can be factorized further. So x plus 2, it's going to be 3 and 2. It's two numbers that multiply to negative 6 and add to 3. So it's going to be positive 3 and negative 2. So that's basically how we factorize a quadratic. Okay, so using the factor theorem, we work out one factor, then use long division to work out the quadratic factor, and then we can factorize the quadratic to give us the two factors. Okay, so that's basically the lesson for today. Have you got any questions?